Hello, in this video I'm going to go through the computation of the f-test statistic, and I'm going to use problem 3 from the section 13.1 homework as an example. I did not find a handy way of doing this in StatCrunch, so I'm actually going to use Excel to pretty much go through the by hand calculation. But I'll show you all the steps and explain why this hint is here and how I got this number. What makes this problem come to us in a form that isn't useful in StatCrunch is that they give us summary statistics. There are 3 populations, 3 samples, they're all of the same size, and they give us the sample mean and the sample variance for each. What I'm going to be doing is computing this definition of the test statistic by essentially following the steps on page 623 of your book. So it comes to us in this scenario, and it gives us all the steps here. I'll also link on the page where I post this video, I'll link to a pretty good multimedia video within my lab on how to actually do this, which shows kind of a whiteboard version of what I'm doing here in Excel. So first thing I did is I took all this data and I put it into Excel. I actually have everything up here already, but I'll rebuild it as we go. So these are the 3 populations. Those are the sample sizes. Those are each sample mean and each sample variance. And what I've done is I've gone ahead and created column headings for the other steps in the f-test statistic calculation that we're going to need. First one was degree of freedom, which is essentially just sample size minus 1 in each case. So to do that in Excel, you type an equal sign to tell it that you have a formula. I go ahead and I click on the cell location that I want to use in the formula, minus 1. So once I have that, I can then take that thing and drag it down, and what it does is in the place where I created the formula it was B2 minus 1, but when I dragged it down it became to B3 minus 1 and B4 minus 1. That's what's meant by a relative reference. The copy and paste maintained the relative spatial relationship between the place where I called the formula and the location of the variables used within the formula. So similarly, I'm going to need degree of freedom times variance for each sample. So what I did there is just do variance times degree of freedom for each one. So again, you can do that quickly by typing this. I can use my mouse to click that, and then you can copy and paste or drag down. And in one of the components I'll also need sample size times sample mean. So same thing is going on here, sample size times sample mean, and that's happening for all of these, sample size times sample mean in each case. And I will also need sample size times sample mean minus overall mean squared. So in order to do this one, I'm going to first have to find the overall mean, and that's why this problem gave us this hint. This is essentially just a computation of the mean. So what I have here is, in these cases, I will need the sum as well. So I just took the sum of all sample sizes, and that's what the book calls n. It's the sum of all the ni's. The sum of the sample means doesn't have real meaning. Sum of sample variance doesn't have real good meaning. But the sum of all the other columns does have good meaning. So I just went ahead and copied this sum formula, which you can do by typing equals sum and then highlighting the range you want. And you can copy and paste that wherever you want it. Okay, so what's left is remaining how to do this calculation. The book defines k, which is really the number of samples you have. In this case, k is 3. I just typed a 3. N is the total of all sample sizes. In this case, it's 30. I typed the sum of these samples. And then x bar. Well, x bar is the execution of this formula. It's each sample size times each sample mean, adding those together over all samples divided by the overall n. And so what I did is I computed that here. This was the each sample size times each sample mean. Then I found their sum, and then I divide by n. So for x bar, you can see I just type this sum divided by n, and it gives me the mean. And so now I have a location for the overall mean, which I can then use in this formula. So what I do here is I'm following this out of the book. It's, I'll type it over, equals sample size for that row times, open parenthesis, sample mean for that row minus the overall mean. And now in Excel, you can type F4 when your cursor is at a cell reference. And what it will do is insert $signs before the letter and the number of a cell reference. That changes a relative reference. That is one that would change accordingly by copying and pasting into what's called an absolute reference, which is a static reference, just B9. And since in all rows I want to refer to B9 when I'm referring to X bar, I want to use those $signs. Close parenthesis, the caret, which is shift 6, and the number 2 gives me a square. So this is the component out of the formula, which is shown in the textbook and in the multimedia video. So I have that. Again, I can drag down, and then this was the sum of those values. And now I've done this basically just going through all of the parts that are needed for the calculation of MSE and MST. So MSE ends up being just the sum of the degrees of freedom times variance for each sample. So that's the 990 number in F5 divided by the total degrees of freedom, which the book would also call n minus k. It would be 30 times the number of minus the number of samples. So that's this formula here, 990 divided by 27. And then MST is this sum, right, which are the weighted square deviation from the mean, and divided by k minus 1. So in my formula, I'm taking equals that divided by open parenthesis k minus 1. And that's how I get that. And then F is just the ratio of those two. So it's MST divided by MSE, and that gives me the F value. F test statistic 17.18, which is what StatCrunch wanted, rounded to 2 decimal places. So I think that's probably the fastest way of computing the F test statistic when you're presented with summary data. When you're presented with raw data, you can actually use StatCrunch to do it relatively quickly.